4 x 4 probability of success and power x 4. How much will be the Q? 0.67. And how many failures?
4.
All successes, no failures, right? Good. Can you tell me how much will be the 4C4, please?
1.
You got 1. And how much is the second term? 0.0119. And how much will be the power 0? Always 1. 0.0119 is the answer. It's a 0.0119. Uh-oh. Oh, 3 decimal places. 2. Excellent. Thank you. Can you do that? Okay. So, please remind what was the binomial model. Always the random variable binomial, the number of successes. It is the probability function, 3 terms. How many? Success, failures, take the multiplication. Simply, we can take the mean, we can take the standard deviation, and we can take the variance. Okay? So please remind what was the binomial. If you didn't homework yet, yeah, please do. Yeah, stay, take a picture. Yeah, it has only 2 questions. Yeah, try tonight. Good. I think last time, briefly, I introduced you the Poisson model, right? Did I ask you the number of texts you received last time? Yeah, yeah. You know, because the binomial model, the possible value for x is actually, it began from 0, no success. 1 success. 2, 3, 4, 5. Up to only n. But the Poisson, there is no limit. It started 0, 1, 2, 3, 4, it's the same as the binomial, but it's going to infinite. That is the Poisson distribution. So, in this, and we need the lambda, and lambda was the mean and the variance in the Poisson model. So, what kind of model? We are going to use the Poisson. How much was the lambda? 3 in a minute. And we took just 1, x equal 1, right? Did I? Yeah? E negative power. How many lambda was? 3. 3 and power x. How many x now? 1 here, 1 and 1 factorial. Can you tell me how much will be e to the negative 3? Power negative 3? 0.0498. How much will be 3 power 1? 3 itself. And how much was 1 factorial? It was 1. So can you do the multiplication? 0.0498 times 0.3. How much?
0.1494.
0.1494. Good. It is the probability I will have only one customer in 1 minute. Very small. It's less than 50%. Why? Because we expected 3 customers in a minute. 1 customer, yeah, is only 15%. Good? I think I did this one before. No?
Yeah.
We just did right there?
No, it is one.
I think so.
Yeah,
That's possible.
yeah. But actually it was at least one. It is not only one. It is at least one. It is not just one, but it was at least one. So please look at here. At least one. Probability. At least one. What does it mean? At least one.
100.
1 or greater. 1 or more. It is the same as 1 or more. You know, actually the Poisson model began from 0, like as the binomial, right? So 1 or more, it is the same as the probability x equal 1 or add x equal 2 add x equal 3. But unfortunately, the probability x equals something, the something is going to infinite. We can't take the infinite sum. Impossible. But how about this? When I add another probability, probability x equals 0, add all possible probabilities, how much will be? How much would be the whole summations?
1.
Yes.
That girl.
Any kind of random variable. Any random variable. When we sum up all possible probabilities, even infinite, it will be 1. It must be 100%. Let me show you the Poisson. Before I showed you the binomial in Excel, today I will show you the Poisson in Excel. So let me put the mean here. Mean was 3. And the Poisson started from 0. 1, 2, 3, going to infinite. So let me go down enoughly. Can you stop me, please?
Stop.
Thank you. Yes, you start me at 109. It is big enough. Let me take a probability. Yeah, go to the function, statistical function, and we need a probability from the Poisson. It's a p. So yes, here. Before we use the binom.dist for the binomial distribution. For the Poisson distribution, we have to use the Poisson.dist. So let me take this function x. Yeah, here's x. Mean 1, 3. I don't need the cumulative one. It's a false. 0.049787. Let me copy down. Oh, where it is? Oh, on the note. Oh, I erased. Do you remember how much was x equal 1 in the example? Say again. 0.1494. We got 0.1494. Yeah. So it was the probability at x equal 1 from the Poisson model. Yeah. Let me copy down. You stop me at 1 or something. Yeah, here. See? Can you see the probability at 109? Do you know what is the meaning of the E negative 126? The scientific notation? What does that mean? 0.000. How many zeros?
126.
Yeah, it's a 0, 0, 0. Very small probability. What does that mean? You know, actually, we expected only 3 customers in a minute. What is this? It is a probability I will have 109 customers in 1 minute. Impossible, right? Let me take the sum. You know, actually, I have to take the sum up to infinite, but 109 is big enough. I have to take from B2 because at B1 there was the mean 3. So let me take from B2 at x equals 0, 122, 109. How much was the sum? 100%. Right? Even up to 109, it is 100%. The remaining probabilities, it will be nothing. It will be nothing. Because 109 is big enough. Yeah, see? Okay? Can you understand? Right? When we add up from 0 to infinite, all possible probabilities, that will be 1. Okay. But now, we need a probability here. This one. Any idea? When I subtraction probability x equals 0 here on the right hand side and do again on the left hand side, I can delete. I can cancel them out. Right? Now we have the summation is actually what we wanted to get. Left hand side, it will be 1 minus the probability at x equals 0. So it will be 1 minus probability x equals 0. Very simple. It is very simple. The summation of from 1 to infinite, it will be same as 1 minus the other probability. What is this rule in chapter 5?
Complement.
The complement rule. Yes. Yes, it is. So now, don't forget 1 minus, right? So let me try 1 minus the probability x equals 0 for the Poisson, which was e power negative lambda. How much was the lambda? 3. Now, how much is the x? X
0.
equal to 0. And x factorial. Can you tell me how much was e to the negative 3? 0.0498 times. How much would be the 0 power? 1 Can you try 0 factorial, please? Do you know where is a factorial? Go to the place where you got the C function in the binomial model. How much will be the 0 factorial? 1, yes. So it will be, don't forget 1 minus, 0.0498, and it is point what? 9502. What is the probability? 95%.
What's the
We can expect we are going to have at least one customer, one
It's a button.
or more customers in 1 minute. Yeah, it makes sense because we had 3 customers on average before. It's more than 1, 95%. Yes.
What's the E?
E?
Yeah, on here. Am I supposed to push a button?
Don't ask me. There's a E.
Where's the E?
Oh, on your calculator?
Yeah, what are we doing with it? What?
Where's your calculator? Mine's over here.
Here, the blue one.
Okay,
There is a E.
okay.
Yeah. You know, when I was in teaching program, I took the oral exam. It's actually the oral exam is there is a 2 faculty members, the committee members, and they read the problem, and I understood, and I solved on the board. Yeah, in front of the 2 faculty members. Yeah. One of the faculty members read the problem, E something, right? But you know, in Korean, E is a 2. It is a E. So he read, Deho, write down the problem on the board. And he read E something. I wrote E something here. Right? I couldn't solve it. And you know, it is an exam. It's an oral exam. It's a test. So he suggested me, Deho, I said E, and I answered, I wrote E several times. Suggest me, oh, it is not E. I wrote E. I was a little nervous. E is a constant. E is a constant. How much was it? 2 point something.
2.7.
Yeah, 2 point something. Yeah, it is a function. It is a function. So do you have an idea? Whenever you have the probability at least something, you have to apply the complement rule. At least 1, or at least 2 or more, 3 or more, you have to apply the complement probability. 1 minus the others, the beginning probabilities. Yes, that is the remaining parts. So now I can say it is 1 minus 0.04 what? 98. So 0.9502. At least 1. At least 2. You have to apply the complement probability. 1 minus something. 1 minus the other one. Good? Right? Okay. Why don't you look at the last one? It is the last part in chapter 6. Who was 3? Who was 3? It was the mean. 3 customers in 1 minute. Right? We had, on average, 3 customers in 1 minute. How many customers do you expect in 2 minutes? 6. The lambda will be 6. Okay? We have to take another rate, is another lambda. The new lambda. 6 in 2 minutes. And now we have to take the probability, no customer, x equals 0. Again, E, negative, lambda, now it is a 6. How many x? X.
6.
6.
Oh, come on, x.
Zero.
Oh, sorry.
X was a 0. 0 and 0 factorial. Can you tell me how much will be e to the negative 6 power?
Okay, no.
Yeah, please do right now, right here.
0.0025.
0.0025.
How much will be the power 0? With the power 0? 1. How much will be the 0 factorial? 1 again. What is the probability? 0.0025. In this case, x equals 0 was, it's about 5%. Why it is much smaller? 0.0025. Who was this? 0.0498. No customer in 1 minute. We had usually 3 customers in 1 minute. Who is this? 0.0025. No customers, 2 minutes. Usually we had how many customers in 2 minutes? 6 customers. Can you understand why it is much smaller than this one? It is the no customer in 1 minute based on 3 customers. It is the probability no customers in 2 minutes based on 6 customers before, right? Yeah, it is much smaller than this. So now, can you understand what is a Poisson probability model? Yeah, it's almost the same thing. Let me summarize here. It was the binomial Poisson. We need a lambda. Lambda will be the mean and the variance later. Probability in x, x was the number of and something 2. Probability function. It's a totally different. E minus lambda, lambda x, and x factorial. What is the possible values for x? It is the same thing. It is the same as the binomial from 0, 1, 2, 2, positive infinity. How much was the mean? The lambda. How much was the variance? Lambda 2. So the standard deviation, we have to take square root of it. Okay? In chapter 6, at the beginning, generally, we discussed the random variable. How can we get the mean? How can we get the standard deviation? Please remember the 6 steps to get the standard deviation. And we had 4 kinds of common random variables. Bernoulli trials, uniform model, they are the simplest one. And then binomial model and the Poisson model. How can we define the random variables? How can we take the probabilities? Who will be the mean? Who will be the standard deviation? It is a very easy way to get the mean and to get the standard deviation. We don't have to apply the 6 steps to get the standard deviation. That was the general formulas to get the standard deviation. So please summarize what we did in chapter 6. Any question? Chapter 6, the random variables. Okay. When you go to the document sharing, in this morning, I'm sorry, I have to do before. This morning I posted the lecture note, chapter 7. Yeah, so we are going to do chapter 7 today. Yeah, this one. Okay, let me do here. How many variable types we had in chapter 1? How many variable types? 2. Who are they?
Qualitative.
Numerical and
Categorical.
categorical, yes. Only 2. Categorical and the numerical. In chapter 6, random variable. Which one? Random variable was
Numerical.
numerical. Thank you. In statistics, we have another 2 types of the numerical variable. One is the discrete, and the other one is the continuous. Discrete, countable. Continuous, uncountable. Look at this. Number of successes. No success. 1 success. 2 successes. Countable. Up to n. Binomial model, it is the discrete random variable. Also, it was a number of something too. No customer, 1 customer, 2 customers, even going to infinite, countable. Poisson, it was another discrete type random variable. You know, any random variable in chapter 6, it was the discrete random variable, chapter 6. What is a continuous? Uncountable. Okay? Can you tell me how am I tall? My tall height?
How tall are you?
Yeah.
I guess.
Yeah, yes, yeah, absolutely.
5'5". 5'6".
How do you think?
5'4".
5'4"? Okay. He said 5'5" and 5'4", right? Can I take another height between these two? Yeah, why not? Can I take another one? Another one? Another one, right? Continuously. How about the weight? 100, 200, we can take another one in the middle, 150. Between 100 and 150, another one, 125, another one, another one, another one. Weight, continuous. How about the blood pressure? Another one, another, yeah, continuous. That is a continuous, uncountable values. Continuous random variable. Does it make sense? How about the age? Do you remember how old am I?
21.
40? What did you say?
21.
Oh, yeah, thank you so much. Yeah, I'm 21. Yeah. Am I exactly 21 years old?
Not far from it.
Yes, actually I'm 46, right? You know, my birthday in May. Today is in October, right? I am 46 years, 5 months. Am I exactly 46 years, 5 months? It's actually my birthday is May 20. Today is October 5th, 5, right? My age is 46 years. It's actually 4 months, 15 days. Am I exactly 46 years, 4 months, 15 days?
No, you gotta think about time.
Time, yeah, I was born in 11 at night. At least, right? Age. You know, when we measure the age only in years, 46, 36, 21, right? Yeah. Thank you. It might be countable, but generally we can say age is another continuous random variable. Anyway, yes.
I got confused a second ago. The Poisson model, you said it was discrete,
Yes, it is. It's countable.
but I thought it deals with variables that go into infinite, so that would be continuous. That was
It doesn't matter. It doesn't matter going to infinite or not. It doesn't matter. But it was countable.
Okay, alright.
Countable, not countable. It is the key.
Okay.
Discrete, countable, continuous, uncountable. It doesn't matter. It's going to infinite.
Okay.
Infinitely countable. Right? Yeah. So, in chapter 6, we discussed the discrete random variables. In chapter 7, we are going to discuss the continuous random variable. But the normal distribution, it is the most popular, the most common. It's not only continuous random variable, but it is the most common one in statistics. Anyway, the normal distribution, it is the continuous one. So please look at this picture. It is a normal distribution. Normal distribution can be defined from negative infinite up to positive infinite. Continuous, uncountable values. Okay? And the normal distribution is mean and standard deviation. Binomial needed N and P. Number of independent trials, probability of success. Poisson, it needed only the lambda. Lambda was the mean. The normal distribution, it needs the mean and the standard deviation. So please look at this picture. How much is the mean for the normal distribution? Who was the mean? Who is the mean? Why?
It's in the middle.
Mean was the measure of the center. At center, there is a 0. 0 is the mean, yes. The standard deviation, yeah, it is another Greek letter, sigma. It is for the standard deviation. Who was this? It was sigma for some, but it is a capital letter. I mean the capital Greek letter for sigma for some. This one is a small letter, sigma for standard deviation. Okay? So it is the normal distribution with the mean 0 and all standard deviation sigma. Plus and minus 1 standard deviation, there is a probability 68%. Plus and minus twice standard deviation. Actually, standard deviation was a measure of the spread. You remember that, right? It's a plus and minus 2, there is a 95%. Plus and minus 3 standard deviation, there is a 99.7%. As I told you, the normal distribution is defined from negative infinite, positive infinite. how much will be the probability from negative infinite up to the positive infinite? How much will be the probability from negative infinite
100.
up to positive infinite for the normal distribution?
99.
No.
I was just guessing.
What was here?
1.
1. What did I say?
1.
When? Yeah, I said 1. Thank you. Your English is so good. When we add additionally probability x equals 0, and I said it was 1, and I told you when we sum up all possible probabilities, always 1 for any kind of random variable. Discrete type, binomial, Poisson, it doesn't matter. Normal distribution, continuous, sum up, uncountable, infinite probabilities from negative infinite up to positive, it doesn't matter. Sum up, it is 100%. Just up to 100%. Right? So, now I can say, even plus and minus 3, there is a 99.7%. So now I can say, here is a negative 4 standard deviation. Here is a positive 4 standard deviation. I can say it is almost 100%. Almost. What does it mean? Less than negative 4 standard deviation is almost nothing. It's almost nothing. Did you remember the probabilities in Poisson at 109? At 109 here, there was almost nothing. Can you see the probability? E negative 126.0000, right? Yeah, 0. Nothing here. It's the same thing. Less than, based on the normal distribution, the bell shape, less than negative 4 standard deviation, there is nothing. Bigger than positive 4 standard deviation, there is nothing too. Simply I can say plus and minus 4 standard deviation. There is almost 100%. Plus and minus 3, 99.7%. Plus and minus 2, a little bit smaller, 95%. And plus and minus 1, there is a 68%. Okay? So, now we can take probabilities. It is an area. It is an area under the curve. Yeah, under the normal curve. That is a probability. So now I can say it is 68% probability is here, plus and minus 1. And here, it is a 95% here. And from here to here,
No, we can't see it.
there is a 99.7%. And finally, from here to here, plus and minus 4, there is almost 100%. So under the curve, the area, it will be the probability for continuous random variable. Does it make sense? And it is the normal distribution. So we are going to use the normal distribution. Again, take the mean. Already mean was given. We are going to take the probabilities. Okay. Please look at this example. Let me give you a very special normal distribution. It is a special one. Normal distribution. Mean equal to 0. Standard deviation 1. It's very special one. Only when mean 0, standard deviation 1. We call it standard normal distribution. And we are going to use the notation, the Z. It is the standard one. Mean 0, standard deviation 1. It is a standard normal distribution. So let me make the picture. Let me make the picture again here. Here's a bell curve. Mean was 0. So please look at this. Less than negative 1.23. Negative score, 1.23. On the left hand side, negative 1.23. Because the value 0 in the middle is a mean. Less than, negative 1.23. Is it left hand side or right hand side? Left hand side. Less than, negative infinity here, right? So we need the probability. Is it here? Just a second. It was the probability function, right? It was the probability function for the Poisson. We have a probability function for normal distribution. Yeah, why not? Look at this. The probability function is do not copy. No, erase. Yeah. We are not going to use this, but I just introduced you. It is the probability function for the standard normal distribution. Now we need the area. Did you take the calculus? Do you remember what was the notation of this one? Have you ever heard the integral? Integral is the technique to take the area from negative infinity up to negative 1.23 and dx. You don't know? What's this one? Do you want to do this?
No, thank you.
We don't have to. We don't have to. Do you know why? Because somebody did. Somebody did. When you go to My Math Lab again, also I posted the Z table. Yes. Let me open the Z table. When you open the Z table, here is a negative Z scores. It has 2 pages. Please print out the Z tables. We are going to use the Z table every day. Yeah, please bring the Z table next week. I'm sorry, I posted it in this morning. So please download and print out the table next week. Every day we are going to use the Z table. So here is a negative Z scores. On the next page, it has 2 pages. There is a positive Z scores here. How much was the Z score? Negative, right? Let me go back to the note. The Z score was negative 1.23. So let me go to the first page. Oops. Yep, good. Here's a negative 1.2, right? But we had second decimal place. How much was it?
3.
3. So
Here is a second decimal place in Z, 0.03. We had negative 1.23. It is the probability. It is the probability. Somebody did. 0.1093. 0.1093. It is 0.1093 here. Easy. Let me try the second one. Less than positive 2.34. Less than where? Left hand side or right hand side?
Right and left.
Less than 2.34. Left or right? Left. Less than.
Oh, you're okay. Can't read that.
Now we can go to positive page. How much was the z-score? Positive 2.3.
4.
2.34.
0.9904.
0.9904. Can you take the probability? 0.9904. Good? Right? Somebody did case by case. We just go there, go to the z-score, -1 and the +1, 2 pages, and we can take the probability. That is the answer.
Can this be our test?
Yes. Yeah. Why not?
Now what about D? Thank you.
Just a second. We can do one by one. Don't worry about that.
Oh,
It is bigger than 50%, right? It's bigger than 0.5. Why bigger than 0.5? Okay, let me ask you. How much is the probability there?
50%?
Why?
because half.
You know, the whole area from negative infinity up to positive infinity, 100% exactly. The normal distribution, bell shape, symmetrical, just cut half, it is 50%. Right? The red one, part B, bigger than 50%. Does it make sense? The part A, less than 50%. Right? The black one is less than green area, less than 50%. The red one is bigger than green, bigger than 50%. Good, right? Why don't you look at part C? Okay, in the middle, there's a 0. Let me erase this one too.
It's
Okay.
great.
Bigger than 1.58. Here, positive 1.58. Bigger. Where? Left hand side or right hand side?
Right.
Right hand side. What do you expect? The green area, right hand side will be less than 50% or bigger than 50%?
Less.
Less than 50%. Okay, let's go to 1.5 and 8. 1.5, 1.5,
0.94.
1.5 and 8. This one. How much?
0.9429.
0.94. Just a second. What did you expect it?
It to be less.
Less.
Less than 50%, but it is bigger than 50%. What happened?
Because of it switched.
Please look at this picture.
Is that because it fills in that whole bell curve?
Always the z table gave us left hand side. Left hand side. The probability 1.58. Was it 1.58?
Yeah.
Yeah. 0.9429 on the left hand side. But we need the right hand side. What
Do you
should I
do the
do?
complement?
Yes, 1 minus. 1 minus.
So we were right.
It should be 1 minus point what? What did I say?
Point
9429.
929.
9429. 9429. 9429. How much is this?
0.0571.
Now it is less than 50%. Please remember, Z table gives us only left hand side probability. If you need the right hand side, you
Complement.
have to apply the complement rule, the complement probability. 1 minus left hand side, it will be right hand side. Good? Okay, now part D, yes. Let's do part D. Okay. Negative 3.01. Negative 1.59. We need a probability in the middle. Can you understand where do we need a probability? Okay, in the middle between negative 3.01 and negative 1.59. Let me take the probability. Let me take the probability at negative 3.09. Negative 3.0 and 9. Okay. Am I wrong?
Wasn't it 1? Was it 3 point?
What did I say?
3.01.
Negative 3.01. Negative 3.0. I'm sorry.
So 0.0.
I went too much. Yeah, here. 1. 0.0013. What is the second score?
Negative 1.59.
Negative 1.5.
9.
And what?
9.
It is a 9.
Yeah.
Please copy the two probabilities.
Okay.
0.0013, 0.0559.
Okay.
Did you keep it? Right? Did you keep them? How much was the probability from negative 3.01?
0.0013.
Thank you. How about the other probability from negative 1.59?
Point.
0559.
Good? Okay, now, where is the probability 0.0013?
To the left.
Remember, always the Z table gave us the left-hand side of probability.
So you have
Up
to
to
do the
whom?
complement.
Up to whom?
Negative infinity. No.
From negative infinity up to?
Negative
here.
3.01.
Yes. There is a probability 0.0013. Where is the probability, the other probability, 0.0559? Left-hand side, left-hand side again, up to?
Negative
Yes.
1.1.
So you have to subtract 1 from 0.
No.
No?
Just a second, just a second. Can you understand where it is? Up to here? This one? Left-hand side? Up to there? Where do we need the probability? In the
Between
middle.
them.
What should I do?
Take the mean.
Say again?
The mean. don't wait. So you don't do 1 minus 0.0013. So you do the right hand side. No.
When you subtract 0013 from 0.0559.
Yeah.
It is 0.0559. I'm sorry. Thank you. It is a 0.0559. But I need
That little piece.
only this one, right? But we knew it was 0.0013. How can I take only this one?
Subtract them.
From here out, it is the probability in the middle. What is the idea?
Subtract 0.0013 from
Point
0.0559.
minus 0.0030. 0.0546. Does it make sense? Right? Even though Z table gave us only left hand side of probability, but we can take the right hand side, even we can take the probability between two scores, wherever. Okay? We are going to continue do this one next time, next week. And here's the quiz number 10.